Welcome back to the another session of our data structure journey. Today we are going to introduction of a tree means we just want to know the what is a tree, what are the basic terminology. So let us start it. So this why we go for the So this is the data structure hierarchical representation. So first why we learn the data structure means how we organize the data in such a way that we can retrieve the data efficient way. That is our main objective. In data structure, we in non-primitive, primitive to classification. Again, non-primitive, there are two types of linear and non-linear. We are already covered the linear data structure. What is a array? What is a linked list? What is a stack? What is a queue? Stack using the linked list. Stack using the array. Queue using the linked list. Queue using the array. Linked list also we covered. What is a single linked list? What is a double, circular single, double, circular double linked list? All the things we are already covered right now. We are already know what is a linear data structure, what is the different classification, what are the drawbacks, why we moved from one type of data structure to another data type structure. Then right now we are going to cover that is a non-linear data structure, and first one is the tree we are going to cover. So tree is a non-linear data structure where the information stored in a node and the relationship between the node is represented by the link or edges. Here, what happen anyway, any category of the data structure, our main objective to store the data. So here, what happen in tree data structure, data is stored inside the form of a node, and the relationship between the node is represented by the link or edges. We can say the what is the association between the nodes. We can represent by the links or edges. So it represents a hierarchical structure that used to represent and organize the data in such a way that we can easily navigate and search the information or data we want to retrieve. So this is a simple data structure representation where the information are A, B, C, D, E, F, G, H, I, J, K, L. So these are the information, and the relationship between the information is represented by the edges. So data stored in form of node and relationship or association between the nodes is represented by the link or edges in case of tree data structure. So next we have to learn what is the basic terminology used in the tree. So first one is the root. What is a root? The topmost node of a tree is called as the root node, or the node does not have any parent is called as root node. And exactly, the a non-empty tree must contain exactly one root node and exactly one path from the root to the all the nodes. This is called as the non-empty tree. So here this is in this diagram. So which one is the topmost? Topmost node is the A. So A is called as the root node. There is no parent of the A. That's why we called A as a root node. So next terminology, parent node. The node which is an immediate predecessor of a node is called as the parent node of the node. So in this diagram, A is parent of BC. So now A is parent of BC, B is parent of EF, C is parent of IJ. Next one is the terminology that is the child node. The node which is immediate successor of a node is called as the child node of that node. So in this diagram, B and C. B and C are the child node of A. E and F are child node of B. I and J are child node of C. Then next one is the leaf node or external node. The node which does not have any child node then called as the leaf node. So if it does not have any children, so here in this case A two child is present, so B also two child present, C also two child is present. Now E does not have any child, F also does not have any child, I also does not have any child, J also does not. So we can say E, F, I, J nodes are leaf node of the tree structure. Yes. Then sibling. The nodes that have the same parent is known as the sibling. So whenever more than one node have the same parent, at that time we call this node as a sibling node. So in this diagram, B and C are the same parents is A. So we can say B and C are siblings. Then E and F are both belongs to the one parent, that parent is B. So E and F are siblings. Then I and J are belongs to the same parents. So I and J are siblings. But here E and I, we cannot say the siblings. It maybe looks like siblings, but it is not looks like me because E parents B, I parents C. So whenever both the parents belongs to the same, then only we can say they are siblings. Then ancestor node, a ancestor of a node is of any predecessor node on the path from the node to that node. The node does not have any ancestor is called as the node. So in this case, A and B are ancestor of which? F node. Similarly, A and C are ancestor of I or J. Then descendant, the immediate successor of a given node is called as the descendant of the node. So in this diagram, F can be immediate successor of which node? B node. So we can say B is the descendant of, sorry, F is the descendant of B. Similarly, E is the descendant of F. E is the descendant of B. Similarly, I, C, A, C, C, A. So this is called as the descendant. Then levels. Levels of a node represent the generation of a node. One level to another. If the root node, if the root node is 0, then the next node is level 1. Branch interval is called as the level 2. Generally, in tree data structure, the level of root node we call as the 0. Then onwards 0, 1, 2, 3, 4. So in this diagram, root is 0, then level 1, then level 2. And it will go to the n level. So next we have to know what are the properties of a data structure. So first property is the recursive data structure. A tree can be defined as recursively because the distinguish of a node of a tree is known as the root node. The root node of a tree contains to link to the all the root node of its subtree. So let us take an example. In this case, what happened? If we go to the A, A is a root node. After that, this is a subtree. Then what happened? Another subtree is, which one is the subtree? B is a subtree. If we go A, C and this is also a subtree. This is also a subtree. So if from root A, there are three subtree. If we move to the subtree, this subtree, then what happened? We can treat as a B is a root. From B root, this is a subtree. This is another subtree. Again, from this B root to, if I move to the another immediate subtree, then what happened? We can think as a B is a root and this is a subtree. Similarly, from B, if I move to this subtree, if we make F as a root node, then this is also subtree. Similarly, if I go to this side, A is the root node, this is just subtree. Again, if I move to this one, then what happened? D is a root node and this is a subtree. So that's why what happened? It recursively represented. So this is a tree, then this is a tree, this is a tree. So it can be represented as a recursive data structure. Then number of edges. If there are n number of nodes, then there would be n minus 1 edges. So if inside a tree, if there are n number of nodes, then how many edges possible? That is n minus 1. So in this tree, how many nodes is present? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. So there are total number of nodes is 12. Now let's calculate the edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 12 minus 1, 11. So if there are n number of nodes, so in a tree, then there must be n minus 1 number of edges. Then depth of a node. Depth of a node x can be defined as a length from length of path from the root to the x node. So depth of any node is calculated the length of path from the root. Next one, what is the path? Path means A is a node, B is another node. The one link, the link is present this one, so it calculated as a one path. So there is a one path from one to B. Similarly, if B is another node and C, so if I tell that path from A to G, so 1, 2, 3. So there are three paths. So depth of a X node. So for example, want to calculate depth of B. So B means it is the length from the root. How many? What is the length? Length is 1 because to reach B from root A, we require only one path to travel. That's why the path is 1. Then height of a node. The height of a node can be defined as the longest path from the node to the leaf node. So from that root to leaf node. So for example, I want to calculate height of B. So height of B to longest path to the reach to the leaf node. So this is the leaf node. So 1, 2. So here height of B is 2. Similarly, if I go for D depth is from root to this one. So it is 1. And depth height is from this node to leaf node. So 1, 2. So this is the height. If I want to calculate what is the depth of J means the distance or path from root to that node. Root to that node means 1 and 2. So here the depth of J is 2. If I want to calculate what is the height of J, means the longest path from this node to root node, to leaf node, not root node, leaf node. Leaf node is the K, longest path. Longest path is the 1. So here the height is 1. So this is the way we have to calculate the height of a node, depth of a node. We have to calculate all the things. So next one is what are the different types of tree data structure. So in case of data structure, tree is classified into 6 types. First one is the general tree, binary search tree, height balance, we also call as the AVL tree, red and black tree, and art tree. So these are the different type of tree structure available. So first one is the general tree. General by the name general means a node can have any number of children. Means it can have 0 child or 1 child or 2 child or n number of children. It can be possible. There is no restriction. So at that time it is called as a general tree. It cannot be empty. In general tree there is no limit of degree of a node. What is a degree? Degree is the number of outgoing number of children we can call as the degree means outgoing edges. Outgoing edges is called as the degree of a node. So here what happened? Any number of children can be possible. So edges can be any number of possibilities. And the topmost of a generality is called as the root node. As we know that is the root is the topmost element present inside the tree structure. Here also topmost element we call as the tree. There are many number of subtree because any number of children can be possible. That's why any number of subtree can be possible. Next category of tree is the binary tree. By the name binary means it is a specialized type of a generality where each node can have at most two children. Binary two. So each and every node has maximum two children means it can have 0 or 1 or 2 children. The degree of node cannot have more than 2 because there can be maximum 2 children. So degree can be 1 or 2 or 0. So the topmost of binary called as the root node and there are many two subtree because each and every node maximum can have two children. So subtree can be of only two. But in case of general tree, what happened? Any number of subtree can be possible because a node can have any number of children. So here what happened? This is a root node. This is called as the left subtree. This is called as the right subtree. Next one is the binary search tree. So binary search tree is a special type of binary tree. Binary tree means maximum two children where every node in the left subtree must be contains a value less than the root node and the value of each node in the right subtree must be bigger than the value of the root node. This is the logic behind the binary search tree. Binary means two, maximum two children, and one more condition is that left subtree value is always less than the root and right subtree value is always greater than the root. So let us take this example. In this example, what happened? This is the 20. So 20. So 20, this is the left subtree. Now inside the left subtree, 15, 8, 5, 10, 18. All elements are less than the 20. And right hand side, that's the 75, 60, 80 and 20. So all the right subtree is greater than the 20 value. Again, for here what happened, the condition should be applicable for each and every node. So this node, the condition is satisfied. Now we have to go to this node. So this is, if we make the 15 as a root node, then what happened? This is left subtree, this is the right subtree. Now left subtree. 8, 5, 10 is less than 15. Yes. Then 18 is greater than 15. Yes, it is true. If it is true, means right now this subtree satisfies the condition for the binary search. So now come to this one. If it is 8 is the root, then 5 is less than and 10 is greater than the 8. So the root left subtree is less than the root value and right subtree is greater than the root value. So this condition is satisfied. So 20 left subtree, all the node we calculated, they satisfy the condition for the binary search tree. Now move to the right subtree. So this is the right subtree. Now come to the 75. 75 is greater than 20. If we make the 75 as a root, then this is the right subtree. So right subtree value is 80 and 90 is greater than 75. Left subtree value is 60. 60 is less than 75. So it satisfies the condition. Now move to this one. If we make the 80 as a root node, then what happened? 90 is the right subtree and right subtree has the more value than the root. So all the node in this data structure satisfy the condition of binary search tree. So this is a binary search tree. Next is the AVL tree. It is a variant of binary search tree. AVL tree satisfies the property of binary tree as well as the binary search tree. Here one more thing added, that is the self-balancing. Here we are introducing a balancing factor. So if it is balanced, then only we can say it is okay. Otherwise, we have to move the nodes. Either we can go for the some rotation like left to left rotation, RR rotation, LR rotation, RL rotation. So for this AVL tree, I will make separate video and we will cover details. What are the basic operation, how to implement in the C language, what is a RR rotation, LR rotation, RL rotation, what are RR rotation. So each and everything I will cover in the separate video. Red black also. Red black is a self-balancing binary search tree. In AVL tree, we do not know how many rotation. Whenever we go for any type of rotation, we don't know how many times we have to go for. But here we know maximum rotation are two required to balance a tree. The balancing can be the balancing factor. If actually what happened, the node balance factors, if range between -1, 0, 1, then it is we call that tree is a balanced. Otherwise, we have to make it to balance. At that time, we are go for some rotation. But in case of AVLT, we don't know how many times we have to go for rotation. But in case of red black tree, what happened? We know maximum two rotation we require. So here it contains one extra bit that represent either red or black color of a node to ensure balancing factor of a tree. For that we require one extra bit that represented either the color is the red color or it's the black color. That's why the tree structure name as a red and black tree. Next one is the split tree structure. It is a binary search tree in which recently accessed elements placed on the root position of the tree by performing some rotation. So here what happens? Self-balance factor, but not explicit balance condition like the AVL condition we are using here. So what are the application of the tree structure? Where we can use the tree structure? What is the data structure? To use to represent in a such a way that we can retrieve the data faster way. If we go for non-linear where the data is stored in the hierarchical way, then what are the application where we can use this data? First one is the storing the natural hierarchical data. This is generally used to store the data in a hierarchical format. For example, we are using the file system. We make a folder C drive, D drive. Even inside the drive, we make a separate folder for the. For example, you are right now learning the data structure. You make a data structure folder. For example, after that you go for artificial intelligence. So what happened? Another folder you make the So how it can be organized? So this is a type of tree data structure. Next one is B tree or B plus tree. These two tree structure we are used to implementing indexing of a database. That is the in case of DBMS we are using indexing to access the data faster way. At that time we are using B tree as well as the B plus tree where the tree data structure is used. Heap. It is also a tree data structure implementing using array. It is used to implement the priority queue. Did you remember whenever I covered the priority queue, I have already mentioned that the priority queue can be implemented by using array as well as using linked. As I have already told, if you throw in the linked list as well as array, so for each and every data structure, we can implement by using the array as well as using the linked list. Reason is that static as well as dynamic implementation can be possible, but I cover only the priority queue by help of the linked list. Why? Because whenever you go for array implementation, at that time we require heap. Heap again classified into two types: mean max heap as well as the max heap. As we did not cover till now the heap data structure, that's why I did not cover the priority queue implementation using the heap. Once we cover this heap, then only we will move back to the priority queue using the mean heap or max heap. Then routing table. The tree data structure can be used to store the data in routing table in the router. So it can be used in that place also. Last one is, or there are so many, this is not last one application we can use anywhere. So it is used to organize the data for efficient insertion, deletion, searching an element. For example, whenever we go for a searching and data in previous case in that we covered that the linear searching. Linear searching is time is order of n means n time we have to search. But if you go for binary search where the data is stored in the binary tree format, at that time the searching an element is a log of n. So that's why it drastically reduce the time complexity. So at that time also you use the tree data structure. Thanks for watching the video. Hope you are able to understand the concept of tree data structure. Please subscribe the channel, like the channel and share the channel. Thank you so much.